welcome back to the channel. And today we have a treat especial, a broken dryer. It is a frigid bitch, affinity, wrinkle release system, energy, something or another, wrinkly, steamy shit we don't fucking use. At any rate, she got to push it about 5 times, of course. It runs, but it ain't making none of that heaty type stuff. It is a gas unit, and I hear a clicking down there when I start it up, which makes me think the solenoid's coming on for the gas. Let me try and let's give her a technical whiff here. So we're gonna pause the unit. I'm gonna disconnect this very well installed dryer vent here. And I'm just gonna breathe in the gas. There's the click. I don't smell anything, so I really don't know. So, at any rate, I guess we're just gonna have to take her apart and see. I have taken it apart once before because I made the mistake of putting too big of a fucking bedspread. That's it. I put too big of a fucking bedspread in there, and she overheated and took out one of her thermal fuses. But these are actually pretty easy to take apart, and don't let them scare you none. So I'm gonna start. I'm gonna get all the shit off of here, and then I'll get you in, and we'll start pulling this little girl apart. Alright, so now that I got the top cleared off, I'll show you really quick what I've got for tools here. This is really handy for any simple homeowner. This stupidly cheap little 26-piece Pittsburgh toolkit. And the thing that's great about it is it's got all your different screwdriver assortments, and it even has standard nut drivers, so it's perfect for repairing appliances and things. And the other thing you want to make sure you have, a multimeter. This is going to be great for checking all those sensors and switches and trying to make sure whether or not they work or they have continuity. So to start taking this bad boy apart, gross, there should be 2 Phillips screws in the back of this lid kind of going in like. So I'm going to choose the number 2 Phillips. See how that fits pretty good. Okay. And I think in order to get these Phillips out of here, I'm going to actually have to scoot the dryer this way a little bit so I can get a better grab at it. So let's move this thing a bit. Alright, so I went ahead and got those screws out. Put the screws somewhere where you want to be careful that you're not going to accidentally lose them. And this lid should kind of pop this direction, kind of back, and then we can actually just lift the lid right off. And then the next step, if memory serves, is I need to remove this front assembly, which I believe, once again, if memory serves, I got 2 screws here, and then I should have, a couple screws down in the bottom here that attach and hold on this kind of lint screen thing in the bottom. So let's pop that apart and see what we've got underneath there. And of course, like with anything, thanks to YouTube, you can look up a bunch of stuff to figure out how to take it apart anyways, but we can always just kind of tug on things and see what happens. Okay, so this just lifts right up out of the way, so that's good. I'm not even going to worry about unplugging that right now. I'm just going to set the controls aside. So that's what it was. There's 2 screws here, and then it might have been screws down below here. So let's get you in so you can see. So let's pop these front screws out. These ones are a bit longer and a little bit different from the other screws. They've got a nice shiny stainless head, probably because these are the ones that the customer would see. Let's see. Don't remember. I want to say there's 2 screws on the inside of this lint trap too. Some of this is coming back to me here. Come on now. Fish that out. Oops. Same kind of stainless screw, though it does have a bit different. That's got like a pan head, and this has got a more decorative kind of straight head to it. So get these two out of here. And then I believe this lint trap assembly comes out of here. It's a really good time to clean the lint trap too, because guess what? The lint screen doesn't catch everything. So, really good opportunity to really get in here and do a really good cleaning. So we're just going to grab some of that, because it's just going to fall everywhere if I don't grab it now. There is another screw in the front here, but I don't think I had to take that out. Well, let's just, let's see, is there on the bottom? Maybe. There might be screws on the bottom here. In fact, I think there is. I think there's a lip down there. Let me take a look here. We'll start by, we'll just pop these screws out and just see what happens, because that'll let us know real quick what's going on in here. So that's allowing this front panel to sit loose but not come off. So I'm thinking, yeah, there's got to be a lip on the bottom. Let me take a look at that and come right back. Okay, so I pulled two screws out that were along the bottom here, and I think now it just kind of lifts off. Yeah, it's just got little tabs. I'm just going to go ahead and close the door. And then we have an electrical connection here for the safety switch. But I'm actually going to leave that connected, actually. What I'm going to do is I'm going to swing this door around the other side here, because I'm going to want that attached for some testing. So, now, normally, a smart person would disconnect the power before taking this apart. But I am not that smart person. And I guess I'm just not that worried about it. Oh, you know what? That's what it was. The screws in the lint trap kind of hold this contraption together that channels the air through. So this one screw in the middle I am going to take out, so I can get this part out of here. And I wonder if I even have to take the drum all the way off or not to test this, but we're going to find out. Look at, see all that lint that gets stuck in there? I mean, this thing has just got all sorts of it in here, and honestly, this is something you want to pay attention to, because it could be a fire hazard as it builds up. So, if nothing else, it's a really good opportunity to really get in here and clean this thing up. So, I think for the moment, we're going to try and fire this thing up, you know, with the front end off, so that way we can kind of get a look and see if we see anything happening. Maybe we'll get a clue as to what's going on. And I bet you I can put this panel right back on here for now. Just set it there. So let's move you in a little closer here so you can try to see what I'm seeing down here. All right, so this is our firebox in here. This is a gas dryer. So what we essentially have is we have a solenoid that kicks on to allow gas through, and it burns in the pipe there. And basically the way it works is it's actually sucking the heat through. So you've got this fan here, and what you've got is suction on this side. So right here, this blowout goes right to the exhaust. So what it's actually doing is sucking air through the filter. So that way, the fresh air is actually coming in right through here, right through where the blower is, to give you the nice big tornado-y hot effect, kind of like a kerosene torpedo heater. And then the heat is pulled up through, the heat comes out of that vent, through the clothing and stuff, and then through the filter, through the fan, and then outside. And you can see they have various safety switches, like this switch here, that if you got too much heat going, if it, like the fan's not working, I think it cuts it off. Oh my God, look at the fan. Look at all the crap in the fan. So I am going to go to town in this thing with the vacuum cleaner, let me tell you. But for the moment, Let's fire it up and see if anything happens in here. Gotta wait for it to finish saying welcome, and then... I heard the click, but ain't nothing's happening. I'm not even seeing any sort of ignition. I don't know if that's supposed to be a hot ignition or a spark ignition, but we certainly got something just ain't happening here. So we're gonna have to dig in closer and find out what the hell's going on in here. Yeah, ain't nothing going on. It's not like it's even trying a second time. It literally sounds like it just did it once and that was it. It almost seems kind of strange to me. Like, I'm gonna pause it. We're gonna do it once more. Because I don't smell any gas or nothing. Start. Yeah, I can't even tell if there's any gas moving in there or nothing. You know what? I think I have another thought we can do to test this. All right, so I have no idea if this is work, but it's going to try it. We're going to try and see if we can give it a manual ignition. Nothing. No flame, no nothing. It really starts to make me wonder if this gas valve is malfunctioning and just not letting any gas through. Whoa! What was that? Oh, spooked me, but I think a piece of dryer lint got stuck in there and suddenly made it more noise. I was like, what the hell's going on? So, I have no idea. So, I think we're going to have to try to investigate this gas valve further somehow, however it works. It's kind of a good question. It's a little different than the gas valve in a furnace. It's actually got two separate solenoids, so I'm not exactly sure how it works. So we're going to have to go in there and try and figure this out. And I think the only way to figure it out is to disassemble the rest of this. And basically, it's really easy, actually. It's a lot easier than you think. We pretty much just have a couple more screws to take out. We can lift this front out, and then the barrel just kind of sits loose, and you just lift the barrel out and slide the belt off. It's really simple. These big nuts are for the bearings. They're kind of like the ones that you see on the inside there, and they do not have to come off at all. They'll stay attached to this piece of metal. So let's dig into this a little further. All right, so I took out those two lower screws on these gray tabs, and I took out two screws here because there's this piece of metal in here that kind of supports and actually holds the computer that controls the whole thing. And I've got one wire for this light, which is just a simple little plug that should just pop right out. A bit of a camera malfunction there for a second. It just unplugs, really simple like. And now I should be able to lift this bracket out of the tabs, that way it's free. And then I should be able to lift this whole assembly up a bit. There we go. There's the entire front piece right there. Set that aside. And so now we've got the drum just kind of sitting loose here. And, oh yeah, the belt. There's a pulley underneath that's spring-loaded that you can reach with your hand pretty easily to untension and take the belt off. I'm going to reach under there, slip the belt off, and then I'll show you that pulley once we have the drum out of the way. Alright, now that I've got that belt undone, the trick that I saw in another YouTube video the first time I took it apart is you can use the belt as a handle to sort of lift and pull the drum right out of here. Pull the drum right out of here. Oh, it's stuck on the motor still. Come on. Got to get the belt past the motor's pulley. There we go. This drum is very lightweight. It honestly only weighs a few pounds. So I'm just going to put this over here where it stays out of the way. Okay. And now we have one very open, very exposed, very dirty dryer. You know, it doesn't take long for this stuff to gather up in here. It was only 3 years ago that I had this thing apart and I cleaned it all out. And honest to goodness, yeah, let's readjust here. All right, shined a little more light on the situation, and we are really in the thick of it now. Look, money. At any rate, so here's that blower we're talking about. Here's the motor. Power going into the motor from the controller. And this is that spring-loaded belt tensioner I was talking about. Really simple. You can move it by hand to put tension on that belt. It's just got a spring on this side here. And it's really super easy to do. It's not bad at all. And I'm not going to lie, I don't understand a lot of these sensors. So like, you know, we've got 2 temperature sensors here. And I don't know if they're supposed to detect if there's an obstruction and it gets too hot in here, but there's 2 of them. So I don't entirely understand. And then there's sensors over here. This is the one that I had to replace last time. Basically, when I had a large blanket in here that was too much for this thing to handle, there wasn't enough airflow, and thus the chamber got too hot, and then this sensor tripped and kicked the unit out. That's got a little tingle to it still. And so, needless to say, it's a safety device, and it honestly only cost me $20 to fix the dryer at that point in time. I'm a little concerned about this valve and what that's going to do / set me back, but I guess there's only going to be one way to find out, is we've just got to kind of dig into this thing and try to understand how this valve works and how this ignition system works. So I'm going to start. Oh, it's not going to be easy to pull that out of there, is there? Because it's hard piped in. What is going to be the best way to gain a little more access to this thing? It's just not really a good way to kind of test and figure this out. I mean, at least at this stage, we can still start it and run it just like we did before. And then kind of, you know, do a bit of a sniff test and see if I smell any gas coming out of this thing or anything. It's interesting. It's not really sure what to think here just yet. I'm going to think on this for a second. All right, so I did a little bit of reading up, and it sounds like there's 2 coils here. Kind of, it sounds like more for like a safety thing than anything, really. It's got to go past 2 seals. They say one is the hold coil. I don't exactly understand it in a sense, because it's like, well, they both have to be open to allow gas to go through. So really I don't entirely know the point other than maybe a safety. But anyways, I think I know what we've got going on here in a sense. It's interesting. One coil has 3 wires, one coil has 2 wires. And what I've done is I've disconnected the coil that is on this side that's closer to the actual burner tube. So just this coil is plugged in. So let's fire it up and listen to it, and we're going to listen for the click. Now there's going to be a bit of a rattling noise because this pulley, unfortunately, is kind of rubbing up against the motor, but whatever. It is what it is. But we're listening for that click sound. Yep, so there was the click. So I'm going to unplug this one, which is just pull it down. And then we're going to plug this 2-wire one back in. And we're going to listen for the click again. I heard no click. No click at all. So my assumption, to be completely honest, is I suspect that, oh, for Christ's sakes, there we go. This forward coil is no good. Now we should be able to actually take measurements. And also, it looks like these coils come off separate from the housing. So if I just take these screws out, I believe this clamp will come off and we can just slide these coils off to take a look. So I'm going to do that, and I think to gain myself a little more access, I'm going to pull this bottom screw out. I should move the money. And see if maybe I can get myself a little more space, though I see there's some tabs in here. That might be troublesome, but we're going to try it. Okay, So I was right. With my stubby screwdriver, I took out these two screws that were holding this plate on, which holds these solenoids in place. And these solenoids are really easy to just lift off. So presumably, I don't know, it must be something inside the rod here. I know I'd seen that there was a different size, so there must be something inside here that is pulled by that solenoid. For the time being, because I've got these solenoids off, I am going to check them, but I'm actually going to put this back on and put these screws in just to kind of keep it all together for now. And just, you know, to make sure I don't break whatever seal is in between these halves, you know. Just to err on the safe side. So I'll put these screws back in and then see if maybe we can run some sort of a test on here with the voltmeter and see what we get. Alright, so one more thing we're going to try and test, because I believe that this solenoid is the cause of our issues. I'm going to see if I have voltage when we get the click on here. So I'm going to hit the start button again, and start button again. I'm not really seeing any particular voltage there. 3.7. So if I hit pause, that small amount of voltage does go away. So it does have me a little bit curious. Oh, you know what? I had this other thing came unplugged. Let me just check. I don't know if that'll have anything to do with it, because this is for the igniter, it looks like. You know, because maybe there's something else causing this solenoid to not fire. I don't know. And so I'm going to try this here. Let's just check it once more. That's strange. It's a little bit higher than it was first test, but it's still less than 1 volt AC current. Now if I unplug this one here, this is the one that we are hearing click. Now of course this has got 3 lines as well. The white and the orange are connected, and then we've got this yellow, which hits the flame sensor. Interesting. So let's just go to the white and the orange, because that's shared with this connector anyways. I'm assuming we're going to get the same result. Just put the probes in there and start. There's that 0.5 volt energy. So let's assume it looks like the white's going to be the neutral. So I'm going to leave my red lead in the white, and I'm going to move over to this other white, which is paired with the yellow on here. Just kind of see. Now static, that's got about 9 volts AC static right now. So let's try firing this again. Jumps up to 2.4. There's the 120 volts right there. So that's kicking on that solenoid. And so my thought here is if that's sourced from, let's see, boy, I don't know where that is being sourced from. That is almost a good question. And these are pretty thin wires that go to, looks like a control. And this is going to a flame sensor here. So as far as how you test that, that's kind of the next question. Because I'm not necessarily sure that this is what's causing my problem. I found some on Amazon for pretty cheap that might be correct, might not. So it might be worth sort of trying. other things that we can do to sort of just try to diagnose. You know, we mentioned that we had this high limit sensor here, and we should be able to actually check some voltage on that. So if I put this to, let's put it in this neutral, right? Let's just try this. Put my black lead in my neutral, and let's see. I gotta make sure I go to AC. Do I have anything here? Okay, there's my 115. It's a good way to know that that circuit's working. Same thing there. I'm going to check this one down here. 115. 115. So that all looks good. Now this little one I'm thinking I don't quite get. I'm thinking, from what I'm trying to understand, is that, so we have another high limit sensor here. Not presumably if it gets too hot, if it's blocked up. And then this sensor down here in the plastic of the fan, I think this is a moisture sensor. Because this unit does have the steam injection thing, it would probably need a moisture sensor. But also, if it has the intelligent dry, where it just dries based on the level of moisture in the air, it would need to know how much moisture is in the air. And it would make sense that it would use this to determine that. And considering these are thin wires, they're just feeding up to the computer. Whereas all these other ones have much thicker wires, so they're actually carrying power. So that makes sense. So this is just a little sensor. These are high limit switches. All these high limit switches are good. So the next question now becomes, am I having a problem with the flame sensor or something else that's shorting out? Now this ignition appears to be like a hot coil ignition. So I could test for power there, but also I could test for continuity. And that might not be a bad idea, because perhaps if that has no continuity, maybe the solenoid won't open at all. Because it almost looks like the power is going through. Let's see. It's almost like the power is passing through this before it hits the solenoid. I'm not sure exactly, but it's kind of seems like a possibility. So I'm just going to set this to my little tone. Let's see if I have any continuity here. I don't. This is a completely open circuit. That really makes me wonder if my hot ignition is what went out, then maybe that's what's causing this to not function at all. Because if it relies on it passing through these wires, which it might, well, I tell you, I just don't know. So that goes to the flame sensor. This is a little more confusing than what I expect, and certainly a little more confusing than the furnace. So it does make me wonder, though, if there is a problem with that. And I almost got to see what it takes to get that out of there. It's a good question. I suppose I could also check for voltage here, because if it is a hot coil ignition, then this should get like that same 115 volts when the system goes to start itself up. So I mean, we can give that a try just to kind of get an idea. So let's put these pins in the connector for the ignition. We've got a static 10 volts. Two and a half volts. So further not really understanding what I'm supposed to be seeing there. I will have to study the owner's manual a bit, or I shouldn't say owner's manual, but diagram. Pretty much any of the appliances that you buy, you're usually going to find this wiring diagram tucked inside somewhere when you open it up. And last time I was diagnosing a problem on this thing that turned out to be that high limit switch, the diagram in here was exactly what led me to the issue that's on the first page here. But for a lot of people, this makes no sense. But I can kind of figure this out for the most part. So I'm going to study this and see if I can't understand it a little more. So going through here, some more testing. I put the solenoids back on. I still have the igniter disconnected. And I looked it up, and it does look like it literally is just a hot wire igniter, which means I should have continuity across it. But I don't. That's making me really think the igniter's the issue. And the flame sensor is a pretty simple 2-wire sensor, so that can be tested continuity-wise as well. And I have continuity there. So I think the flame sensor is fine. So it really is definitely making me think that we have a problem with the igniter. Now, seeing as how the voltage flows through it, that makes me think that we should see 115 on one side of this, and then the other side would have to go, you know, where is our feed on the other end, really? I mean, these wires are way too skinny, but maybe they are, because I see on this side here, bring it on this side so you can see it, we do have a black wire here, and the black wire in these systems is generally referred to as the hot wire. So I'm just going to put this back to my AC test and just see if this wire truly is hot when the system is engaged. Well, let's just try one side of it, right? So our static voltage is 5 volts, and let's just turn it on. There was a little change in voltage there, but nothing. Nothing that I can see there. Let's just pause it. Try it again. Oh, come on. Puzzling, because I would think I would see some level of voltage here. Only like 41 volts. And maybe it's lower voltage than I think. So I think one thing that we can do to try to test this further, which is probably not the recommended idea. Oh, you know what? Did I? Yeah, no, yeah, that was my source. That's right. So I'm going to plug my source back in. Those are such thin wires, but I suppose it doesn't take that much. I want to bypass this. That's kind of like the next thing I can think to test this. Let me see if I can find a piece of wire. Now, I don't necessarily recommend doing what I'm about to do, unless if you're nuts like me. But I'm just going to put this in here, and I'm going to hit the button. And I don't think any sparks will fly. Maybe that would smoke. I don't know. Let's find out. Let's listen for clicks. Woo! Okay. Well, that made stuff happen. But I think it might have taken out the flame sensor at the same time. So that was interesting. That's why I had my hand on the cancel button. Let's see if the flame sensor survived that. I don't think it did. But I think that is confirming more for me, though, what I was originally expecting. I could smell it. Come on, get these in here. The flame sensor no longer tests good. Okay, so at the cost of a flame sensor, that does make me feel a little more confirmed that our igniter is our problem. And this was just a little too much. So I think that's going to be my step here, is I'm going to get the igniter and the flame sensor, which are pretty cheap on Amazon. They're like less than 20 bucks each, I think. Or actually, I think the igniter's like $25 and this is like $17. It's not bad. I think I'm going to get those parts, and when they come in, we'll give those a try and see if we had any luck. But I told you it wasn't a good idea, but this is how I learn. Trial and error. Well, got the new parts in. So now we just got to see what we have to do to disassemble and replace these parts. And then this is that little hot coil igniter I was talking about. And I don't know for a fact on this, but my guess is you're probably not supposed to touch that. So I'm just going to avoid touching that because it's very porous, and I get the feeling the oils in your skin could actually cause a premature failure of that. I'm pretty sure that's why I had one premature fail on my furnace. So now I just got to figure out what I have to do to pop this apart, considering I don't really want to have to dick with disconnecting gas line, but I probably shouldn't have to. So there's a few screws. So I'm going to take a few things out and see what I can find out. Alright, so here's what I got so far. I disconnected some screws on these two legs, but that doesn't move a whole ton. There's a screw there that's kind of hard to get at, and I removed a screw that holds this onto the tube, but I still couldn't move it out enough, so I removed the screws that mount this gas pipe to the floor, but obviously the gas pipe is secured back here, so you can see that little tab right there. I took the screw out from the back side, and I was able to kind of pull the gas line through here a little bit, just enough that I can get at the screw for the igniter. So that'll take care of the igniter. And then as far as the flame sensor is concerned, I've got to kind of look under there. Now, normally, it would be easy enough just to shut off the gas and disconnect the gas line. But my house is old, and you can see it's got a pretty old gas valve there, and it's not leaking. So I just as soon leave it and not touch it unless if I really need to. You know, it's like, I mean, look at the one for the water heater too, and the cobwebs. It's like, I don't want to fuck with it and then suddenly have it start leaking on me and just give me more problems than I need. So I managed to squeeze it out enough here that I know I can get the igniter out of here. I just got to figure out what is holding the flame sensor in. Oh yeah, it's got a screw on the bottom, but it looks like there's enough space that I can get that with a stubby screwdriver. Alright, well luckily with this whole thing moving, I was able to pretty easily get my stubby screwdriver underneath there and pull this fine threaded little machine screw out. And this guy's just got a little tab, it looks like, holding it in. There was a screw stuck in there. It's interesting. It's like, how does this work? What do it do? It's not like anything I've ever seen before, that's for sure. It's very strange. But we got it out. So it looks like the new one got the same bracketry on it, so that's pretty good considering it was a, you know, $15 Amazon part. Well, I guess let's swap the wiring over. We can get that back in, and then we can get that igniter out. Alright, I got the new flame sensor mounted back up in there. And I got the screw for the igniter loose. It's already unplugged, so I should be able to lift it kind of up and right out of here. And she looks fairly chooched. Oh, look, there we go. Oops, I'm sorry, I'm not even on the camera. I say she looks a little on the chooch factor here. Can I get it to focus on it, maybe? Kinda. But yeah, there is, see that bright spot right there? Hard to see in the camera, but there's a crack in it right there. You know, if it was easier to get out, I would have checked that a lot sooner, but it's kind of a pain in the ass to get out of there. So, all right, well, we'll check, and it looks like the connectors are the same, so that's good. So we'll get that tossed in there and put it all back together, cross our fingers, and we'll see what happens. All right, so I got the new igniter installed, and you can kind of see that there's a little tab on the top here that it just kind of sits in this little notch, and then just the one screw goes on the bottom. It's pretty simple to install. And obviously be careful, like I said, not to touch the element. And I did check, that is what they say as well. So yeah, that's pretty cooked. So now I've got the 2 new parts installed. Let's see if I can slide this thing back together. And I don't even know where this screw came from. It was stuck in there. I don't even really know, to be honest. But who knows? Now I just gotta slide this pipe back through here, which looks like it's gonna be a 2-hander. All right, so I got the screws all back in. I basically started, once I had the pipe all the way through, I started with this screw to kind of pinch the halves together. And then I was able to just start these screws in the bottom, but they have slots, make sure these ones lined up and got started. And then I was able to tighten those down. So this is pretty good. I think we're going to do a test. Now, given, I'm going to cancel it right away because the flame is not going to shoot through the tube like it's supposed to. And it's not going to because the drum is not attached to create the actual suction that we need. But we can at least check for some operation here and shut it down pretty quick, and we should be fine. In fact, I'm pretty sure last time I was working on this, I had done the same thing when this high limit switch had gone out. So let's hit some buttons here and see if we get any glow. All right, here we go. So that's a difference. I don't know if we had any gas flow, but I think the safest way to test this further is to toss the drum back on and then try to give it another test run and see what happens. So let me reassemble some things here. It's pretty easy. I'm just going to hang the drum back on and then reach underneath and throw the belt around the pulley here, around the motor's pulley, which is that one, and just kind of pull this by hand and slap the belt on. That's pretty easy stuff. Yeah, so let's get that reassembled. All right, so I've got the drum here, and basically I'm going to set the drum on top of those little roller skate wheels, and to make it easier, these kind of flex around, so we pop them to the open position. And then we're just going to take the drum in here. Just kind of set it on those wheels, let the belt hang. Controls here. And I could just kind of let this drum sit like this. Let's see, it's actually not all the way in, so just, there we go, lift it up, make sure it's sitting on those wheels. And then to support it, we need to put the front cover in place. Now the front cover also has 2 wheels at the bottom, and the front cover has, on these tabs, it has these little notches in the top tabs, so that way the front cover will hang in place. So I can kind of lift the drum into place, put the wheels underneath the drum, so that way the drum is now hanging there, and I can kind of push this in by hand and just kind of set this little tab inside the hole. Do the same thing on the other side here. There. So now the drum is supported in there correctly, and we can put these screws in, and so I'm going to do that next. Alright, so I got the 4 screws down in the corners done, and now there's this bracket that holds the computer, and that actually sits inside here too. It's got a couple of little silver tabs that just protrude, and then there's the screw holes to put those 2 screws in to hold that in place. That kind of helps create a rigidity of the system as well as a place to mount that computer. So that's pretty painless. Now that that's in, I can also rerun this little wire, which is just for the little light that's inside the drum here, which they've got this little indentation for the wiring. And then it's got a little spot on the board, which is right on the end of the board here, I believe. Yep, there we go. Put a little bend on that to keep it out of the way. So now the drum should spin. Yep, spins nice and easy. So I just got to reach down there and get that belt on now. Nope, it's not really any easy way to show it, but there we've got the belt riding on the pulley now. And so now when I spin the drum, you can see the motor spin with it. And it spins nice and free. So that's good. So, just got to put the plastic back on here that controls the airflow. And I cleaned this all up, so this should be much better than it was. Screw that guy in place, and then get the front cover on, which will have the door, and then there'll actually be airflow. Now, some dryers actually have a hole in the front cover here so that you can look through and see if your burner's running. This dryer doesn't have that, so we're going to make a hole. That way we can find out for sure that it's running and feel a little better about checking it in the future. Alright, so next up we're going to put that front cover assembly back on. Just going to make sure that this wiring is connected and not getting pinched by anything. And the cover's got a couple of lower tabs that kind of help set it where it needs to be. And then I realize those bolts actually go through both pieces. So, well, what do you know? Things you forget over time. So I actually got to take these two screws back out because they have to pass through both halves. All right, let's try this again. Those in there. Sometimes you got to kind of squeeze the little halves together. Like that. All right, now we have two screws along the bottom, but we also need that hole that we talked about. So let's take a look at that. All right, well, I got those two bottom screws in, and it's just a lot of feeling and guessing. And, you know, if you tilt the dryer back a little bit, it's probably not too bad to get on, but I was too lazy to do that, so I just felt with my hand and I found the spots. So now, some dryers have a little access port right here. It's often covered up with like a little square piece of plastic or something that you can pop out, and that's so that you can check on the burner. And this one doesn't have it. So what I do have is a 1/4-inch drill bit that I happen to have in the house here anyways. So I'm just going to use that. Just right here. I think that'll be good. It's also probably a really dull drill bit, so that's awesome. Well, that wasn't too bad, actually. Let's just... There. That'll be fine. Now we can find out if she lights up and operates. All right, so I've got us focused into the hole now. I hit the button, and we're going to see what happens. See anything yet in here, huh? Oh, there's a glow. Okay. Oh, look at that. She lit. All right. Sweet. As I imagine, I've read it's a very low PSI, so I'm sure it's not a super huge flame by any means. But I do believe we have a working dryer now. I guess I'll load the bitch up and we'll see. See, look at that tiny little hole. Does the trick. Look at that. Focus. All right. So, yeah, I guess at this point, I just got to put the rest of it back together. As cool as this is, you know. But yeah, making sure the wiring's in the right spot. I still have to put the 2 screws in that hold this in place and then slide the top cover back on. But she's running, so time to test her.